Everyone, this is lesson 11.1, Circumference and Arc Length. You might be wondering why we did 2 lessons in Unit 10 and then now we're jumping to Unit 11. However, as you will go through this lesson, you'll see why we incorporated it, because we talked about the measure of the arc, which is the angle, and now we're just going to talk about the length of the arc. So we're just going to do 11.1 and 11.2 and then jump back to Unit 10. And then your first quiz will be over 10.1, 10.2, 11.1 and 11.2. And that's actually most likely going to end up being a take-home quiz over this long weekend. So just so you're looking ahead into what's coming next. So first we're going to do a little warm-up investigation about area and circumference. So it says to find the circumference of a circle with a radius of 12. So the formula for circumference is 2 pi r. So that means we're just going to plug in 12 in for r. So 2 pi times 12 would be 2 times 12 is 24, so 24 pi. And this is what we call leaving your answer in terms of pi. If it says to round your answer, then you would type in your calculator 24 pi and use the pi button on your calculator, not 3.14. And then state the circumference formula. Well, we already did that, so just copy that back down here. Part B, find the length of an arc intercepted by a central angle 90 degrees on a circle with the radius of 12. So it's the same thing, except you're just taking 1/4 of 24 pi. So because 90 degrees is 1/4 of the circle. So 1/4 of 24 pi would give you 6 pi. Okay, so that is the area, that's the arc length of just this arc rather than the entire circle. And then C says to find the length of an arc intercepted by a central angle 90 degrees on a circle with the radius, this is supposed to say 60 degrees, with the radius of 12. 12. So 60 degrees would be 1/6 of the entire circle. So 1/6 of 24 pi would give us 4 pi. So in today's lesson, we're going to learn a formula that will give us the arc length of any arc, not just 90 degrees or 60 degrees. Okay, now let's jump over to area. So the formula for area of a circle is pi r squared. So it's r squared because area is units squared. And then there's no 2 in front. Think of it as the 2 here, transferred over to the 2 up here. That actually is not a coincidence. That's something that you'll actually learn how to derive when you take calculus. The difference between the area and the circumference formula are actually quite related. So it says to find the area of a circle with a radius of 12. So we'll do pi times 12 squared. 12 squared is 144. So we get 144 pi. Part B, find the area of a sector. So a sector is like a piece of the circle or like a piece of pizza. And then created by a central angle of 90 degrees. So once again, we're going to take 1/4 of the area of this circle. So 1/4 of 144 pi. Oh, let's see. I don't have my calculator handy with me. What is 144 divided by 4? 36. 36 pi. And then over here, same thing, 60 degrees would be 1/6 of the circle. So 1/6 of 144 pi. So 144 divided by 6 gives us 24 pi. All right, so here are the important formulas that you need to know for this lesson. So to find the length of an arc, you're going to take the measure of the arc. So we'll do measure of arc AB divided by 360, because in the previous example we did 90 divided by 360, which is 1/4, and then 60 divided by 360, which was 1/6. So we'll take the fraction of the arc and multiply it by 2 pi r. Or it might be helpful to calculate 2 pi r first and then multiply it by the fraction. And then always leave your answer in terms of pi unless it says to round. So that's the arc length. That's how you find the length of an arc. And then the area of the sector is just the same thing except you use the area formula. So the measure of the arc divided by 360, the fraction of the arc that you're trying to find the area of, for the sector, and then times pi r squared. That's the area of the sector formula. Okay, so let's do some examples. So the first thing we'd want to do is to find the measure of the arc. So arc AB is 120 because its central angle is 120 degrees. What fractional part of the circle is this? Okay, so in other words, what's 120 divided by 360? So the first step is to simplify your fraction. So that would be 1/3. Sometimes the fraction can't be simplified, but a lot of times it can. So you want to check first. And then what is the exact circumference of the circle? So we're just going to find the circumference of this circle with the radius of 6. So that would be 2 pi times 6, which is 12 pi feet. And then it's basically asking you to find the length of arc AB, which would be 1/3 times 12 pi, which is 4 pi feet. So that's the length of this arc here. And then this is just reiterating the formula. So number 1 is just to find the exact length of arc AB. So this is 90 degrees. So we would just take 1/4 times 2 pi times 7, which would be 14 pi. All right, so here's an example where the number 14 and 1/4 don't go evenly into each other. So let's first write it as, like, put 14 pi over 1 and multiply it, combine the fractions. So 14 pi over 4, which can be reduced to 7 pi over 2, and then units are inches here. So 7 pi over 2 inches. That's how you would write that. Don't write it like 7 over 2 pi. You'll see it more commonly like this, with the pi in the numerator. Okay, here, AB has an arc length of 135, so 135 over 360, and then times, it says the diameter is 20, so that means the radius is 10, so 10 times 2 would be 20 pi. Okay, so now I need to figure out if 136 is divisible by 360. Sorry, why did I keep saying that wrong? I'm going to check to see what 360 is divided by 5. 72. And then 135 divided by 5 is 27. So actually, what might be easier to do here, let me bring out my calculator, sorry. Go ahead to your calculator and figure out what 136 divided by 360 is as a fraction. So use your fraction button, and that would simplify it for you. So here, alpha y equals fraction button, 135 over 360 gives us 3/8. Okay, so this turns out to be 3/8 times 20 pi over 1. And now before multiplying these fractions together, I can try to simplify 8 and 20, so they both go into 4. So this would be 2 and this would be 5. And then I can multiply across. 3 times 5 is 15 pi over 2 centimeters. So 15 pi over 2 centimeters would be the length of arc AB. Okay, the length of arc AB here, we'll do 45 over 360, and then times 12 would be the radius, so 24 pi. And a lot of you like to think of it as pi times diameter. That's the same thing. So I'm going to check on my calculator what 45 over 360 is. This is the easy part. So 1/8. Okay, so then 1/8 of 24 would be 3. So this is just going to simplify to 3 pi centimeters. All right, so the number 4 is important. So let's look at this one. The exact length of arc AB is 35 feet. So it's giving us the arc length in this example. If the measure of the arc is 20 degrees, what is the length of the diameter? So now we're going to have to solve our problem in reverse. There's going to be a lot of reverse questions on the test, so you want to know how to do this. So I'm going to set up my equal sign. I know that it's equal to 35 pi. And over here, I'll have 20 over 360, or which simplifies to 2 over 36, which simplifies to 1 over 18. So I'm just going to write this as 1 over 18. And then I'm trying to find pi times diameter. All right, so the first thing here I notice is this is an example where the pi's will cancel. So you can cross off the pi's here. And then the next thing is, if we're trying to find diameter, we're multiplying it by 1/18. So to get the 1/18 on the other side, we would have to multiply it by the reciprocal, which would be 18 over 1. Okay, so diameter then would be 35 times 18. 35 times 18 gives us 360. You might be thinking, well, that's kind of a lot, but the arc length was a lot for considering that the angle was so tiny. So that does actually make kind of a lot of sense. Okay. And then let's see. So 11.2 is when we talk about areas. So let's look at this one real quick here. I don't think there's a whole lot. So find the this is the other one where we are finding the diameter, and it's split up into 8 equal pieces. So that means you don't need to divide 360 by 8. You can just write it as 1/8. So 1/8 times pi times diameter equals, this one is important. So the arc length is 6.28. Okay, so what happens if there's no pi over here, so the pi's don't cancel? That means we are going to have to divide by the pi. But first, I might want to multiply by the 8 over 1. So times 8 over 1. So let's figure out what 6.28 times 8 is. That gives us 50.24. Okay, now we're going to divide both sides by pi. And this says to round to the nearest whole number. So I'm going to take that answer and divide it by the pi button is right here above the caret symbol. So I'm going to press blue caret symbol to get pi. 15.991, which they said we can round to 16. So 16 inches would be the length of the diameter. All right, so that is all for this lesson about the arc length. And next you will learn about how to find the area of the sector. Okay, have a great day.